Now it should be clear for you that by this structure it means that item is the name of the stack or array which is having a maximum size so that it can hold only this much of elements. So the name item refer to stack 1 as well as stack 2. Both these are referred by the same name item. Then how do we recognize whether it is stack 1 or stack 2? It is used by this serial number. The value of serial number is 1, it is stack 1. If the value of serial number is 2, it is stack 2. In both these cases, name of the stack will be item only. Then when the value of serial number is 1, we will be handling top 1. Then it becomes item of top 1. When the value of serial number is 2, it becomes item of top 2. Top 1 and top 2 are used for indexing purposes. Value of these two will be changed when we do the push or pop operation. Whenever we do some operations on this item, it has to be affected in the value of count also. That is, when we push a value either to stack 1 or to stack 2, this means that an element is being inserted into the array item. It can be in the left side or the right side depending on the value of this serial number. Then we have to add 1 to count, because push operation adds an element into the array. Similarly, when we pop an item either from the left side or from the right side, we have to subtract a value 1 from the count, because pop operation takes out an element from the array. So that's it. Let us see the algorithm for this push and pop operations. You have to be very clear with these elements used. Item is the name of the list array representing 2 stacks. We are considering multi-stacks, and this identification is made based on this value serial number. It can be 1 or 2 if we are considering 2 stacks for this array. It can go beyond that. I have told you in the previous class, it can go beyond 2 stacks. You can have many number of stacks in it, and if it is 2, we have to use 2 top indexes for handling the push and pop operations, and count is the number of elements at any instance in the array. Some of the elements may belong to stack 1 while the others may belong to stack 2. We can have empty conditions also. If all the elements belong to the first stack, then the elements in this may not be there. The reverse can also happen. So it's not necessary that both these stacks should have some elements. We can have empty stacks also. So this count represents the total number of elements in stack 1 and stack 2. It should never go beyond the size of the list, that is max. So this will be used in the algorithms which follows. See the push operation. We will be providing the address of the stack as well as the element to be added. Push means addition of elements. Element to be added into the stack. So we'll be checking whether the count is max. I told you that count represents the maximum number of elements present now at the array. in the array. So if it is max, we are definite that there is no space either in left stack or in the right stack, which means that it is an overflow condition. We cannot push anything onto the stack. So this is clear. If the value of count is, when s is a pointer, we will access the member count as s arrow count. If it is if it equals the value max, we have a overflow condition. Stack is full. We cannot add any element in either in stack 1 or in stack 2. That is, push operation is not possible in this case. So we will be stopping this algorithm. Otherwise, we have two options. Value of s number. I told you that it can take two values if we are considering two stacks in this multi-stack operation. So it can take only two values, either 1 or 2. If it is 1, we assume that it responds the left side of the array, and if it is 2, it belongs to the right side of the array. So let us see if it is 1. If s number is 1, we have the same operation that we have seen for single stack. That is, we will be incrementing the value of top 1. Top 1 gets the next index. And if it was 4, then we have to make it 5 and assign the value item of s top 1, s item s top 1. Hope it is clear to you. If s is the pointer, we will be identifying the array item as s arrow item. If top 1 is the index, we will be identifying the index as s arrow top 1. So the element will be represented as s arrow item of s arrow top 1. At that location, we will insert this element passed. So an element is added to the list. So when an element is added, we have to increment the count of element. That is, s count is made as s count plus 1. This is a simple operation what we have seen in previous cases. The working will be like this only. We will be increasing the index value, assign the element. Those were the two steps followed for push operation if the condition is not an overflow state. Now let us go to the other end of the stack or array. That means serial number is 2. If it is 2, we cannot increment the value of index. Instead, we are coming from right to left. That means we have to decrement the indices. So we will decrement the value of top 2 to top 2 minus 1. For example, if the value of the top index of the second stack was 8, then the next element will be at the location 7. That means 8 has to be decremented to 7. Therefore, this step will be executed. S top 2 will be made as S top 2 minus 1. After changing this index, we have to assign the element passed. That means an element is pushed towards the right end of the array. Again, one element is being added. Therefore, we have to increase the count value. The only difference is when we are pushing item at the left end of the side, we are incrementing index value. If it is on the right side, we are decrementing index value. After making changes in the index value only, we are assigning this element. In neither of these case, we have to increment the value of count. and while incrementing it should not exceed the value max. If it reaches the value max, we are sure that there is no space left for addition of element either in the left side or at the right side. So that is the push operation. Similar is the case with pop operation. We can pop from either the left side or the right side. It depends on the value of S number. If S number is equal to 1, we are popping a value from left side. For that we will be checking whether it is an empty space or empty stack towards the left. How will we do that? If value of top one is -1, it is an empty stack, is it not? If the value of top is -1, it is empty. We cannot pop anything from that. Otherwise, it is not empty. We are popping an element and we are assigning the top of the element to a variable called pop. Then we are changing the index. How? S of top 1 is made S of top 1 minus 1. This was the normal case we have considered earlier. In that case, one element has been removed from the list, so we have to decrement the value of count also. So there is no confusion in this area, that is when we are considering the left side of the array. It is being considered when the value of S number is 1. If it is 2, we are considering the right side of the array. I have told you that the invalid condition for that index location is max. If top 2 value is max, we are sure that there is no item left at that location, at that portion of the array which belongs to stack 2. So it's an underflow condition, and if it is not max, we can make sure that some elements are present, at least one is present in the stack 2. So we will be popping out the topmost element. Topmost element in this part is recognized by the value of top 2. It is being assigned to a temporary variable pop, and this index is changed. While we are changing the index here, it will be opposite to this one. That is, we will be instead of decrementing the value of index, we will be incrementing the value of index. So top 2 will be incremented, just opposite of the push operation we have done with this side of the array. Then in this case also one element is being removed from the list, so we have to decrement the value of count. So here again the difference is this one. When we are popping from the left side, we are using the same structure or equation that we have done before. We are decrementing the value of top 1. When we are popping from the right side of the list, we will be incrementing the value of top 2. In either of these cases, we have to decrement the value of count. Finally, we will be returning the copied element to the calling function, return popped. So this is the pop operation. Hope it is clear to you. Push and pop operation in multi-stack when we are considering just 2 areas of a string as 2 stacks. They are identified by the value of serial number 1 and 2. Actually, they have the same name item according to our definition. Difference is made out by this value of serial number. Okay.